Hello, welcome back to this training. So today I'm going to look at how you can derive your odds ratio for case control studies and relative risk, and then also we'll link it up to the calculations for sensitivity and specificity. All right. So first of all, uh, my name is Anthony, and in this tutorial we're going to just have a look at what is odds ratio first. So this is Wikipedia. All right. So odds ratio is simply the ratio of the ratio of the odds of a disease or of an event happening to the odds of that disease or event not happening. All right. So that's the simplest term. So now odds ratio is used in case control studies. Most times it's used in case control studies. And like I said, case control studies are backward looking studies. Okay. There are studies that are looking backward. That means somebody has a disease, right? And then you are now taking history to see if they had an exposure, whether they were smoking or whether they were not smoking. All right. So the disease has already occurred, and you are trying to uh, take a history, look backwards to see and to identify the various risk factors that could account for this cancer. And then by the time you identify those various risk factors, then you're going to calculate the odds ratio in order to know the particular one that has the highest odds ratio. So, for example, if someone has cancer, you have a group of people that have cancer. All right. So you are going back, asking different questions, maybe genetics, all right? Maybe cigarette smoking, um, Indian hemp, okay? Maybe um, dust inhalation, just dust inhalation. So the various risk factors. So in this group of people, you ask them questions, all right? So now these are called the cases, right? Now you have the control group. The control group are those that are also similar in to the cases, right? You're also asking them the same kind of questions that you ask these people. The same kind of questions you ask. So they are similar to the uh, cases, except that they don't have the disease. So they have similar age, all right? They're in same similar age, ethnicity, okay, religion. So they are all similar. So the process of making sure that the control group is similar to the case group as much as possible is called matching. Okay, it is called matching. The process whereby you ensure that the control group in a case control study is as much similar to the uh, uh, cases apart from the disease. That is called matching. All right. And the purpose of matching is to what? Reduce bias. All right, bias in case control studies. So that matching is one of the techniques of reducing bias. All right. So bias simply means anything that can uh, produce a spurious result in an experiment. So we don't want our results to be spurious or invalid. That's why you do matching. So they are matched based on age, based on gender, based on other social demographic variables apart from the disease. So now so these are the cases and these are the control group. So you now ask questions. You now ask them questions to determine the various risk factors that they might have. All right. So by the time you have finished asking um, asking the cases and the control groups in the case control groups, so you have asked them questions, you get maybe you have five major risk factors, right? So let's say you have smoking as number one that is still exposed to. You have um, alcohol intake as number two, and then you have maybe taking Indian hemp as number three of the major risk factors. Now we have looked at different studies, okay, in literature, and I've said that smoking can cause lung cancer, right? Alcohol can cause lung cancer. Indian hemp can cause lung cancer. So what do? You're going to calculate the odds ratio for each of them. You're going to calculate the odds ratio for each of them. So the one that has the highest odds ratio is likely the most important risk factor for that disease. All right. So that is the importance of odds ratio. That is how you derive it. All right. So today I'm going to look at how do we calculate it. So first of all, we're going to look at the 2 by 2 table, and then we're going to merge it. So we are not going to cram formulas. I'm going to show you the formulas here. The formulas, like I've told you, is odds of exposed to the odds of the ones that are not exposed, right? Okay. Now, so to calculate your odds ratio, you have your 2 by 2 table. So these are the disease, those that have the disease, those that don't have the disease, right? Now, this is those that are exposed and those that are not exposed, right? And then this is the total number, and then the total number, right? So for you to so let's say we have 20 people that have disease here, 30 people that don't have the disease, and then the total number here is 50. Then um, you have 40 here, and 20 here, and here is 60. So total is 50 plus 60 is 110, 30 plus 20 is 50, 20 plus 40 is 60, right? So how do I calculate my odds ratio? As simple without cramming. So odds, what does odds mean? Odds means the uh the probability that something will happen divided by the probability that it will not happen. So the odds of a disease will now be what? The odds for the exposed group. So for the exposed group, their odds for the exposed group now, their odds will be what? 20 over 30. So take note that I'm not using the total here, right? I'm not using 50. So it's just the odds of having a disease divided by the odds of not having a disease, 20 over 10, right? For the exposed group, right? Now, for the non-exposed group, what is the odds? Odds for the non-exposed is what? The odds for the non-exposed is 40 over 20. All right. So that's the odds for the non-exposed. So I'm not using the total. So it's very important for you to get it. All right. So now how do I calculate the odds ratio? So the odds ratio will now be what? The odds for the exposed group, which is 20 over 30, okay, then divided by the odds for the non-exposed group, which is what? 40 over 20. All right. So if we press that in the calculator, we remove all the zeros and remove all the zeros. So 2 over 3 divided by 4 over 2. So 2 over 3 divided by 4. 2 over 3 is 2. All right. So 2 over 3 divided by 2 will give us 2 divided 2 over 3 divided by 2. All right. So that will give us 0.333. You see? So our odds ratio, so therefore, our odds ratio here is what? 0.333, which is what? 33% or 0.33. So how do you interpret a negative. How do you interpret an odds ratio that is less than one? Okay, so when the odds ratio is less than one, that means that what? As the exposure increases, right? Then the probability of having the disease will what? Decrease. So when the odds ratio is less than one, this is how you interpret. Okay, so the more exposure, the lesser the disease. So now, because the odds ratio is less than one, what will I do? So I will say what? That there is a negative association between the disease, between the exposure and the outcome. That's how to interpret the negative association. All right. When the answer is more than one, there is a positive association. When it is when there is no difference. Right, so when the answer is equal to one, then there is no relationship at all between the result and the outcome. All right. So this is the first statement. Then the second statement is that what? When the odds ratio is less than uh, when it is less than one, for example, if the exposure is vaccination, so it means that the odds ratio, it means that the exposure is protective. Okay, okay, it means that the exposure is protective when the odds ratio is less than one for vaccination programs or for intervention programs to reduce a disease. All right. So now, how can we know the amount of protection? How we can know the amount of protection is what by doing 1 minus 0.33. That will be what? 70. So that will be 0.7 or 70%. So I can say, assuming that the exposure is vaccination, I will say that the vaccination, that those that are vaccinated have um, sorry, that those that are vaccinated, that the vaccination reduces the incidence of the disease, reduces the risk of having the disease by 70%. Okay, so that's how to interpret it for odds ratio that is less than one. Okay, and whereby it is a drug or is an intervention, to reduce the disease. Okay, so when the odds ratio is less than one, it is protective. All right. So, and that means that there is a negative association between maybe the vaccination and COVID-19. All right. So this is how you do your odds ratio. All right. So, so if the odds ratio is more than one, so let's say we have um so let's say we have an odds ratio. So let's say we have an odds ratio now, and then our odds ratio is equal to one. So here we would say there is no association between the exposure, which is the vaccination, and the disease, the outcome, which is COVID-19. Now, if the odds ratio is anything like between 1 to less than 2, so let's say 1.8, how will you interpret this one? So you will say that the odds of having the disease increases by what? It increases by 80%, because this 1.8 is one. When you do 1.8 minus 1, that will give us 0.8. So it's a positive value, which is 0.80. If you convert it to percentage, that would be what? 80%. So the odds of having the disease increases by 80% among those that have among the exposed group compared to those that are not exposed. All right. So that is how to interpret the odds ratio when it's between when it's between one above one but less than two. All right. Now, when the odds ratio gets to two now, anything from two upwards, so you can say that the odds of having the disease is what? Two times more. Okay, among the exposed group compared to the non-exposed group. So the odds of having the disease increases twice. Okay, so this two times more simply means 200%. Okay, that's the meaning of that. So instead of saying 200%, 300%, just say two times more, 2.5 times more, all right, among the exposed group compared to the non-exposed group. Okay, so currently we have seen the odds, how to interpret the odds for the various types of odds ratio, the figure that we might guess, all right. So this time around, we are going to look at the relative risk. So what is relative risk? Relative risk, also called risk. Okay. So relative risk means what? They comparing the incidence of a disease in the exposed group to the incidence of the disease in the non-exposed group. So you draw over your 2 by 2 table again, disease, no disease, again, total, right? Okay. So you have 20, 30, 50, 10, 15, 25. Total is 75. So here you have the exposed, not exposed, right? Now you have here you have 45, 30 plus 15. Here you have 30. Okay, and then here this is the total here. So how will I calculate my relative risk here? So now, what is the risk in the exposed group? So here I'm going to use the total now. So I'm going to use what? 20 divided by 50. So for exposed group, okay, so what's the risk now? Incidence of the disease, so I will be 20 over 50, right? Now, for the non-exposed group, what will be the risk? The risk will be what? 10 over 25. So that will be 10 over 25, right? Now, so what then is now the relative risk? So the relative risk will be what? Incidence in exposed group, so 20 over 50 divided by 10 over 25. All right. So you punch these figures. You have 2 over 5 divided by 10 over 25. So let's see what is going to give us 2 over 5 divided by 10 over 25. So 2 over 5 divided by 10 over 25. So what? So it's giving us 0. Oh, sorry, 2 over 5. Okay, 2 over 5 is 0.4. So okay, let us say 2 over 5 is what? 2 over 5 is 2 divided by 5. 2 divided by 5. That will give us 0.4, right? Then 10 divided by 25. That will also give us 0.4, right? So you can see here there is no, so we're having 0.4 over 0.4. That'll be what? 1. So how will you interpret this figure? So how will you interpret it? Because it is only 1, so we'll say what? That there is no association between the exposure and the disease or the outcome. So when relative risk is equal to 1, there is no association. When relative risk is less than 1, let's say for example, sorry, when it is less than 1, you will say what? That there is a negative association between exposure and outcome, right? Then when the relative risk is above 1, say what? There is a positive association between the exposure and the outcome. All right. So let's interpret a relative risk of 0.67. How would you interpret that? Like I told you, this is what? Protective is less than 1. Okay, so depending on whether it's a drug or an intervention, is going to what? Reduce the incidence of the disease. So how will I get it? So I will say what? 1 minus 0.67. That will give me 0.33, so which is what? 33%. So I will say that the exposure reduces the incidence of the disease or the outcome by what? 33%. So that's how to interpret it when it is less than 1. Okay, or you can say those that are vaccinated have um, a lower chance of contracting the disease. Okay, so you can say that the exposure reduces, the vaccination reduces the incidence of the reduces the risk of, sorry, not incidence here, it's a mistake, it shouldn't be incidence. So you will say that the risk of having the disease decreases by 33% among the exposed group, which is those that are vaccinated, compared with what? The non-exposed group, that is those that are not vaccinated. So that is how to interpret this. Okay, so you can take time and watch this video. Now, when the relative risk is more than 1, let's say it is 2.5, for example, so you can say that the risk of having the disease increases to 2.5 times among the exposed group, that is those that are vaccinated, compared to the non-exposed group. All right. So take note of the interpretation. So if you are talking about the relative risk, we are talking about risk. The risk of the disease increases by or decreases by. If you're talking about odds ratio, here you will say the odds of a disease increases by or decreases by. So take note of the different things. They have different calculations, right? So relative risk is used in core studies. So what are called core studies? So core studies are what? Forward-looking studies. So you get two people, those that are smoking and those that are not smoking. Then you throw them up for 10 years to see how many of them will get lung cancer and how many of them will get no cancer. Among the smoking group, same thing here. How many people will get cancer and how many people will not get cancer, no cancer, right? So by the time you get all the figures here, so let's say you have 20, 30, 10, 40. Then you will now do your 2 by 2 table like we did before, and then calculate your relative risk. So that is just a little bit about cohort studies, right? So take note that case control and cohort studies, they are all called, they are all grouped as observational studies. So observational studies can only say that there is an association between exposure and the uh, the outcome of the disease, but they do not prove causation. So they do not prove that the exposure can cause a disease. All right. It's only when you do a randomized control trial, that is the gold standard, and then you also add the Bradfield criteria, right? So these are the requirements for you to say that something is causing a disease. All right. Okay. So let's go straight to this. So now that I've understood how to calculate it, so We are still going to use the same table again and do for sensitivity and specificity. Now I'm still using the same table. Okay, nothing has changed. Watch, this is exposure, exposed group, and then this is the non-exposed, right? You know the brain learns by association. So I'm still using the same damn table, okay? All right, so we have 20, 30, 50, we have 35, 20, 55. So you have 105, 50, 55, and you have total. Now I'm going to use this table for sensitivity and specificity, specificity if you're doing your tests. Okay, so now I'm going to change this E here. I'm going to put plus here as a positive test and minus here as a negative test, right? So I'm going to ignore this exposure and NO. I'm going to ignore the two. All right. So what am I going to do here? So I want to go. I'm going to do something here. I'm going to say, this test I'm going to ask one question. So I'm going to say, is this test telling me the truth or is it lying? Okay. So let's put the test result first. So here is saying that this is plus here. Okay, this plus here is saying everything here has the disease. Why this minus here says everything here has um, don't have the disease, right? So I will say, okay, the test result said negative here, said negative here, right? Now it said here positive and it said here positive. So that is what the test result is telling me. So but now I'm going to ask myself, is it true in reality based on this table? So now look at this one. It said that these 20 people are positive. Is it true? Look at my heading. It said this is true. Okay, then I'll put true here. Now, this one, it says that they have disease. 30 people have disease. But my heading is saying no disease. So this is false. See? False. Here, the test result is telling me that 20 people don't have this disease. I'll check my heading. Okay, it is telling me the truth. So I'll put my truth here. Now, here, the heading is telling me, here I saying that 30 people don't have disease, but my heading is telling me that they have disease. So it's lying. All right. So having done this, how do you calculate your sensitivity and specificity? So sensitivity simply means what? Those that have the ability of the disease to detect the disease among those that have disease. As simple as that. So sensitivity is equal to what? As simple as that. 20 over what? 55. You see that? So 20 people that have the disease. So you can see that this test have a low sensitivity because out of it, 5 people that actually have the disease, it was only able to tell me the truth of just 20%. So it's very low, right? Now, so let's look at specificity. Our specificity here is the ability of the disease to tell me, okay, these people they don't have the disease among all the people that don't have the disease, right? So among 50 people that don't have the disease, how many people would this test tell me the truth? It said only 20. See, 20 over 50. So you can see that this test has both a low sensitivity and a low specificity. So you can just press the calculator. 20 over 55 will give us what? 20 over 55. 20 over 55. That will give us, oh, what's going on? Okay, that will give us 36.3%. So it has a low sensitivity, that's 3.6%. All right, then 20 over 50, that's 2 over 5, which is what? 0.4. So that is 40%. So it has both low sense. So this test has a low sensitivity and low specificity. So now let us confirm our calculation. What we did now. So we go straight to the Wikipedia. Simple. So let's look at this one. So sensitivity, also called recall or hit rate or true positive rate, is what? True positive over total number of positive, right? So now, and the total number of positive is true positive plus false negative. So let's look at how we did it without cramming those formulas. So this is the true positive right? Which is 20 divided by the total number of positives, which is what? 55, right? So now look at this one. So if you break down this, you say it's called, it says positives refer to true positive plus what? False negative, right? So can you see true positive here and false negative here? So you don't need to cram the formula. All you need to do is to understand the simple logic. Just master the table. That's all. All right. So look at our specificity. True negative over total number of negatives. Right. So look at our table here. True negative is 20. 20 over total number of negatives, that's 50. Right. All right. Now it now says what, that the true negative is equal to, sorry, the total number of negatives is equal to true negative plus false positive. So let's see whether we got it. True negative plus false positive. That's 20 plus 30, 50. So you don't need to cram the formula, just understand the simple logic. All right. So now, having said that, we will now talk about the positive predictive value and the negative predictive value. The positive predictive value here will be what? Now remember that in sensitivity we went vertical, in sensitivity and specificity we went vertically. But in positive predictive value and negative predictive value, we're going to go what? Horizontally. See, so this is the plus sign here. So positive predictive value will be what? 20 divided by 50. So that will be what? 20 divided by 50, and that will give us what? 40%. That's 0.4, right? While our negative predictive value here, we go horizontally again, that will be what? 35 divided by 55, right? So 35 divided by 55, that will give us what? 35 divided by 55. Okay, so 35 divided by 55, 35 divided by 55. That will give us what? That will give us 63.6%. So 63.6%. See that? All right. So that is how to calculate your negative predictive value. All right. So I hope this makes it simple. You don't need to count the formula. Just understand that in sensitivity and positivity, you go vertically, while in positive predictive, positive predictive value and negative predictive value, you go horizontally. All right. So having said that, we go straight to interpreting logistic regression. All right, so let me give a note about logistic regression. Okay, so now when you talk about before that, let's talk about correlation. So when you talk about correlation, correlation means that what, as A is increasing, B is also increasing. All right, so so if in every research has an outcome variable, and also you have the predicting variable, predictive variable, or you call it the independent variable, variable. So that is the variable that the researcher will manipulate to generate results. So that's what I call results. That's the outcome, right? So if you have smoking here, the smoking can be the independent variable. Smoking and alcohol intake, okay, can be the independent variable. Why the outcome with what? Lung cancer, right? Or increase in blood pressure, depending on whatever you are measuring. So when you talk about correlation, you are saying that two things are going in one direction. If you draw the graph, this is how the graph will look like. Straight line, either positive, but that's for positive correlation, we're looking like a straight line going like this. While for negative correlation, it will be going down like this. It's this negative correlation. So let me claim this. So this is your x and this is your y. So like I told you, x is what? The independent variable, right? Y is the outcome of your research, right? So in correlation, you are saying that things are going in the same direction. Increase x, y will also increase. So this is called positive correlation, right? But negative correlation is that as you are increasing x, y is decreasing. So this is negative correlation. All right. So so that is about correlation. All right. So just understand the basics of what it means, so that when time we now look at the example. All right. So now now when you talk about linear regression, it's all about straight line. We all know that the equation of a straight line y is equal to mx plus c, where m is the slope. All right, slope. All right. So yc is the intercept. So linear regression is all about something moving in line with a straight line movement. Okay. So now now our y is the outcome of your research, what you are measuring. While the x represents the independent variable or the predictive variable, right? So this slope, a positive slope, if the slope is positive, this is how the graph will look like. Okay. Now, if the slope is negative, like I told you, this is how the graph will look like. The equation of the straight line. Okay, so you have y is equal to mx plus c. So where this m will now be a negative number, right? All right. So this is your y and this is your x. So let's say as you are increasing alcohol intake, the risk of lung cancer, the number of people that have lung cancer will do was increase. Sorry. As you are increasing, um, for let me delete this one. So for a negative slope here, where x is, let's say, exercise, a number of number of hours you exercise, that's your x, and then your y is what? Let's say the risk of heart attack, right? So so that means that, so what, and then let's say the slope or the slope is the slope or coefficient here is um minus 5. Okay, so your equation will be what? Y is equal to minus 5 x. Okay, x is the number of hours, then plus c. C is the intercept where this thing cuts the line. C is just a number. All right. So our y is what? The risk of having heart attack. So from here I can see that the risk of having a heart attack for every 1 hour, for every 1 minute increase in the number of hours one exercise, the risk of heart attack reduces by 5 units. Okay, the risk of heart attack reduces by 5 units. So that's how to interpret this. Okay. Now, when this is a positive slope, when this is a positive slope, like this, going forward, like this is y, and this is your x. Now, where your x is maybe like number of bottles of alcohol, right? And your y is your the risk of having a heart attack again. Okay, so let's say this time around, the equation of the straight line is y is equal to m. So our slope now is positive. So let's say it is now 3. Okay, 3x. Okay, 3x plus c. C is a constant. Okay, that's the intercept. It can be any number. So how will I interpret this? I will say that for each unit of alcohol, for every additional unit of alcohol taken, the risk of having heart attack increases 3 times. Okay, so this just is a practical application of how to interpret. So here the emphasis is not to do the mathematics in calculation. The emphasis is in MPH. The emphasis is you being able to interpret. the results of any article that you are reading, being able to understand it. So this is basically um, how a linear regression looks like. Okay, so having laid this foundation, one more thing I need to discuss is um, so I've talked about linear regression. So let's talk about logistic regression. So what does it mean? Logistic regression, remember here, our y is now logistic, binary logistic regression. So when I say binary, that means our y has a yes or no. That means, or it has two variables. Okay, all right. So you have two variables. Then you have your mx, you have your the slope are interpreted the same way, and then your your constant also there, but then but now the equation will now change. All right. So, but just know that in binary logistic regression, the outcome variable, that means the result of your study, is two. So you are trying to predict whether somebody will have a heart attack or not. So that's a kind of yes no prediction. All right. So the nature of the equation is not like it's not as simple as the straight line equation. So, but I'm going to show you an example. All right, in the next PowerPoint that's following. So, when your research is framed in such a way that the outcome variable is you are trying to predict an outcome, whether something happened or not, then you are dealing with uh, binary logistic regression. Okay, okay, all right. So, all right. So we're going to look at practice questions for regression and a question for t-test. Okay, so the first question on the screen. Now, if you watch, this is a two sample test. So that's a two sample t-test. Now, when you hear about t-test, it's all about comparing the difference in means. Whenever you are doing a research and the your hypothesis is structured in such a way that you can compare the average of two different groups. Then the most likely test that you're gonna use if the data is normally distributed is the t-test or the ANOVA. Okay, so the t-test or the ANOVA, they always compare the average. So instead of just saying that the average of something, the average for group A is bigger than the average for group B, yes, we know that it is bigger, but then we need to test it statistically. Okay, so we need to go beyond comparing the average of two groups and then go to check if it is statistically significant. So if you want to compare the average of two groups, then you use a t-test. If you want to compare the average of two or more groups, you use ANOVA test. Okay, so right now, this is not a tutorial about t-tests, and there are a lot of videos on YouTube around t-tests. So I want to make this video as short as possible. So let's go straight to the interpretation. All right. So now this is a two sample t-tests comparing the birth weight of babies between between mothers, smoking mothers and non-smoking mothers. All right. So you are asked to interpret this on the screen. So now, like I told you, there is always a reference variable. There's always a reference variable. So the reference variable means the the sorry, there is always a reference group. So the reference group means the default value when the researcher has not manipulated any of the independent variables. So what do I mean by that? So, for example, you have the equation of a straight line. This is your y and this is your x. So now the equation of the straight line is y is equal to mx plus c. All right. So now this s can be 1. So when this s, or it can be 2, it can be anything. So when x is, let's say, 7, and then this, when the slope is 2, and the intercept is maybe the intercept is 3. Now what will be our y? Our y will be 2 times 7, 14, plus 3. That will be what? 17. Okay. So now when I mean, what I mean by reference um, group is when there is no default value. That's when the value of x is 0, when the researcher has not manipulated any variable yet at all. Okay. So the reference category will just mean that what you have here, the x value is 0. Okay. And then you have only 3. So y is equal to 3. So it means that the variables in the research, yet. The research has not yet begun. So the default value will be equal to that of the intercept. All right. So that is the meaning of reference category. So let me give another example of reference category. So let's say you are doing a research whereby you are looking at why is the risk of heart disease. Okay. Then we have two independent variables, our M1, X1, and our M2, X2, and then you have your intercept. So now for the M1, our X1 is, we want to say if there's a relationship between alcohol, number of bottles of alcohol taken, and then let's say uh, maybe just our slope is just 3, and then maybe the slope of return is 2. Now, we want to say, is there a relationship between alcohol intake, smoking? So our X2 is smoking, and then the intercept is, let's assume the intercept is just 7. All right. Then this is the heart disease. So this is the formula for a linear, for a multiple regression. Okay. Now, a reference category simply means that we are assuming that everything here is 0. The person has not taken alcohol, he has not smoked, so everything here will be 0. So the default value will be 7. Okay. So we'll now say that on a normal day, for someone that has not taken alcohol and smoking, that the risk of heart disease is 7 times. Sorry, that the risk of heart disease is 7%. Okay, that's 7%. I'm just giving an example. So this is what I mean by reference category. When the researcher has not yet manipulated the independent variables, when there is no independent variables at all. Okay, so by the time you now start adding the independent variables, which is alcohol and smoking now, then the research now starts. So the default value is normally equal to the intercept. All right. So that's just what I'm trying to explain here. Okay, so let's go straight to this one. All right. So here, so this is a t-test. So like you can see now, this 0 and 1. So the reference category here is 0. Reference category here is 0, because we are assuming that 0 is the non-smoking group. Okay, so normally when the in the question, if you don't see any category listed, just assume that the default category is 0. All right, and that's the default or the reference category is normally 0. That is the people that don't have any issues at all. Okay. So, but then if the state is, then that's good. So here, you have number of observations. That's those that didn't smoke is 115. Those that smoked is that smoked 74%. All right. So now the average. So now another rule again is that the numbers that you are seeing inside here is not, it normally refers to the outcome variable. So what is the outcome variable here? We have seen smoking, and then we are seeing birth weight. What is the outcome variable here? Is it smoking, or is it non-smoking, or is it birth weight? The answer is what? Birth weight. So birth weight is the outcome. Why the risk factors, or the independent variables, are the smoking and non-smoking groups. Okay. So so now, the variables that you are seeing inside this table, it normally refers to the outcome variable. So now you can see here that the mean birth weight for the that for the non-smoking group is 0.25, okay, kg, while the mean birth weight for the smoking groups is what? 0.40 or 0.41 kg. Okay. Now, the difference in mean between the smoking and non-smoking groups is what is in negative sign. That is because 0.25 minus 0.40 will give us minus 0.15. So that means what? That on the average, the birth weight of children born to smoking mothers are lower by what? 0.15 kg on the average. Okay. Now that is what only average can tell us, but we need to do t-test in order to see if this average is significant or not significant. So by the time you do your t-tests, you will get that you will look at the p-value. Now, the rule of thumb is that when the p-value is less than 0.05, then the result is significant. 0.05, that is 5%. Whenever it is less than 5%, whenever the p-value is less than 5%, the result is significant. So here it is 0.02, that is what? 2%. All right, so that means that what this result is significant. Okay, so this is the interpretation. All right, so I can say that the risk of on the average on the average that children born to mothers who smoke have a lower birth weight compared to children born to mothers that do not smoke. Okay, or you can say on the average that the birth weight of children born to mothers who do not smoke is higher by what? 15% compared to the mothers that do smoke. All right. So this is all about understanding the English. Just know that you can see here, this is 40%, this is 25%, 0.25. This one refers to the smoking group, zero refers to the non-smoking group. So always the zero category is always for the default category. All right, that's the reference category where the researcher has not yet was interfered. All right. Now, if you look at the confidence interval, like I said before in my first video, the confidence interval here does not contain zero. If the confidence interval contains zero, then that means that this result is insignificant, because remember we are comparing the mean. So the mean cannot be zero, right? The mean, the average, so the mean difference, the difference between the average of this and this cannot be zero, because if the average is zero, that means that, sorry, if the mean difference is zero, then that means that there is no difference in birth weight between the two groups. So if this complex interval contains zero, then that means that what it is not significant. All right, because the mean will lie somewhere within the confidence interval, within this range. All right. All right. So the mean will lie somewhere within um, the confidence interval. So it shouldn't contain zero. All right. So if it contains zero, it is not significant. Then if the p-value is above 5%, 0.05, it is also not significant. But here, it is significant, right? So that is how to interpret your t-test. All right, now let's go to the next one. Now, this is regression results. This is regression, all right? So I've already explained this one. Now, like I was telling you before, the first question is to ask what is the outcome variable? The outcome variable here is what? That's the outcome variable is the exam score. All right. So the outcome variable, you don't normally see a column for it. Is based on the question. All right. So everything I'm seeing here is the exam score. All right. If you look at this one here, you will see that the outcome variable is what the weight of the baby. Because you will not see a column that will say this is the weight. All right. So same thing here. The outcome variable so all these things are exam scores. Now, how do we interpret this one? Now, the intercept, like I told you, it refers to the reference category. All right. So now, what the outcome variable is exam score. The independent variables are number of hours spent with tutor and number of hours studied. All right. So how will you? Sorry, not number of hours. The number of the use of a tutor, which is what categorized as zero. No is equal to zero, and yes is equal to one. All right. So now the reference category is zero. That means like we didn't use any total. Now, how do you interpret intercepts? The intercept is when the researcher has not manipulated any variables. That means when there is 0 hours studied and when the person has not used tutor. So on the average, I can say that when the person has not studied anything and has not used any tutor, the uh, the average score should be 34.98. That's it, and the p-value is less than 5%. So that's less than 0.05. So it is significant, right? That's for the intercept. Now, if you want to interpret the hours studied alone, you if you want to interpret this one now, this here now, you will say that on the average, for every 1 unit increase in the number of hours studied, the average score increases by 4.08 increases 4.08 units. The average score increases by 4.08 units, and this is statistically significant. So for the every 1 hour for every one extra hour studied, okay, keeping the tutor the keeping the exposure to tutor constant, the result increases by 4.08. Okay, now, but if I want to interpret everything together, what will I say? Okay, so I've explained this part, okay, the intercepts, all right. Now, all these things are called the regression coefficients, okay. So if you want to now explain everything at once, okay, so you can now say that what for each additional hour studied is associated with increase of 4.08 points on the final exams. Okay, so sorry, I've made a mistake here. So how you will interpret this is that for each sorry from current slide. So how you interpret this is that for each extra hour studied, the result increases by 4.08 units. While this one for each for students that use tutors on the average score higher compared to students that don't use tutor by 10.7 points. Students that use tutor, because why I'm saying students that use tutor and compared to is because the use of tutor is a categorical variable. That means it has categories, two categories, either yes or no. So on the average, students that use tutors score 10.7 points higher compared to students that don't use tutors. While for the hours on the average students that um, for on the average students that study for every 1 unit increase in hours that the students study, the exam score is expected to increase by 4.08. Okay, where this tutor is kept constant. So the difference between um, multiple regression and logistic regression is such that the equation of a straight line sorry, the difference between multiple regression and linear regression. So in linear regression, the equation is something like this: y is equal to mx plus c. But in multiple regression, the equation is something like this: y is equal to mx1 mx1 plus mx2 plus dot dot dot, okay, that's the infinity, plus mx3, okay, then plus c, which is a constant. So if you want to interpret the impact of the first independent variable, which is mx plus 1, you have to keep the other ones constant. Okay, if you want to interpret the effect of mx plus 2, which is the second independent variable, you have to keep the other ones constant. All right, so trying to apply the same principle here, so you will see that if you are told to interpret this, you will say that for every 1 hour extra that the student studies, okay, keeping the tutorial exposure to the tutor constant, that the student gains an extra 4.08 points in the marks on the average. Now, if you want to interpret this 10.7, you will say keeping the number of hours constant, for every student who uses a tutor, the exam score increases by 10.7 points. So that's how to interpret um, multiple regression. So the next one is this one again, under multiple regression here. All right. So how are we going to interpret this? So this is the outputs from starter. So you're not expected to try learning how to calculate all these things. All you need is to know how to interpret them. All right. So this is the probability. This one and this are the same. See this p value, this p value. All right. So how do you interpret r squared? R squared means the amount of variation in the independent variable. Sorry, the amount of variation in the outcome variable, that's the dependent variable that can be explained by the independent variable. So here I can say that 3.63% variation in the baby weight can be explained by the mother's smoking status. So that's how to interpret this one. Then the p-value is less than 5%, that's less than 0.05, and it is statistically significant. Also, the confidence interval does not contain 1. The confidence interval does not contain 1, so it is significant, and it's also narrow. Do you understand? So it is narrow, implying that the confidence interval is precise. It doesn't contain 1. All right. So now, how do you uh, interpret this one here? So you can, like I told you, the default category is 0. Okay, the reference category. So now that means that what for on the average, the birth weight is reduced by 283 points. Okay, among mothers who smoked compared to those who didn't smoke. All right. So if the confidence interval contains 1, it is not significant. Remember, in odds ratio, when the odds ratio is 1, it means there is no association between exposure and outcome. So the odds ratio is contained within this confidence interval, so it shouldn't contain 1. All right. If it contains 1, it is not significant. Now, this is unlike the t-test, which is the test of difference in means. The difference in means here, the confidence interval should not contain 0. for t-test. Okay, if it contains 0, that means that there is no difference in the there is no difference in between the mean of the exposed group and the non-exposed group, so it's insignificant. So just take note, t-test, the mean shouldn't contain 0. All right, so that is how to interpret that. So let's look at this one. How do you interpret the mother's birth? Okay, how do you interpret this? This is another regression again, multiple regression. Now, like I told you before, same thing here. Probability. This is the probability here is the p-value 0.2165, 0.2165, 0.2165. They are the same. So the p-value is above 5%. That's is above 0.05. So that means this is not statistically significant. Now the confidence interval here contains 1. See, this is a range from -7 to +32. So between -7 to +32, it crossed 1, and it is not significant. So the confidence interval is wide and therefore not precise. All right. So the narrower the confidence interval, the more precise your results. Okay. So R squared here. So I will say that divide this by 100. So I will say that 0.82% variation in the baby's weight can be explained by the mother's age. All right. And then this is not statistically significant. Now, interpreting the coefficients, I would say that remember the age now here now there is no reference category because the age is not a categorical variable. So how I will interpret it will now change. I will now say that for each 1 unit increase in age of the mother, the baby's weight increases by 12.42 units, or the baby's weight increases 12.4 times. All right. However, it is not significant. All right. Then we talk about logistic regression. Like I told you before, whenever you are expecting a binary outcome, okay. So now take note that in uh, so this is multiple regression here. Then in logistic regression, your y is binary. Okay, it has two values. So you are trying to predict something. All right. So your y is binary. You are trying to predict two values here on the outcome variable, okay, using the independent variables. All right. So that is an important difference. Okay, so here in this logistic regression, this is the equation for logistic regression. So this is the intercept. This is the first in the independent variable, second as many as you like. Trying to predict whether an event will occur, and is a log. Is a logarithm. Is a log. The equation is a log. Okay. So this is an example of how to interpret your logistic regression. So for you to interpret, assuming is a binary logistic regression, whereby you're looking at a binary outcome, you need to convert all these numbers because it's a log. You need to convert them back to odds ratio by looking for the exponential. So if I want to find the exponential of this one here, I will say exponential 0.344. So let's do that. Exponential 0.344, exponential 0.344, exponential 0.344. Okay, so exponential 0.344 will give me Google is not giving me exponential 0.344. I'm not getting my distance, but then basically once you press that in your calculator, you will get 1.41. That's the odds ratio. Okay, So you get the odds ratio of this one, and you get the odds ratio of the number of hours. Okay. So from here, I can see that now, like I told you here before, the outcome variable is not normally stated. So all these scores here are talking about the outcome variables. Okay. So now, what is the outcome variable here? That is the probability of passing the final exam. So you can see here that the probability of passing the final exam, if you're using program A, keeping number of hours constant, is what? 41%. If you remember how we talked about how to interpret odds ratio. All right. While the probability of passing your exams, if you are using by number of hours, the, the probability of passing your exams if program A is kept constant is what? 6%. All right. So basically, that is how to interpret. So the emphasis is on interpreting, not calculating, okay, or deriving. All right. So we'll go straight to another example of odds ratio. So this is a starter output. Now you can see, like I told you, the outcome is binary. So now the exposure, that's the independent variable, is the mother's history of hypertension. Now we're trying to predict whether the baby's birth weight will be less than will be above 2.5, or whether it will be less than 2.5 kg. Okay. All right. So now here we are given the we know that our outcome variable is here. So we are seeing we are giving the odds ratio for for those that are for the mothers that are pregnant. All right. So you see here that the odds of having a baby with weight less than 2.5 kg increases by 3.36 times. Okay. You state the confidence interval. All right. For mothers who had a history of what? Hypertension, compared to those who did not have a history of hypertension in the past. Now, like I told you, odds, the confidence interval does not contain one. Remember, it's odds ratio. So the p-value is less than 0.05, that's less than 5%, and this is significant. All right. So with this, I think we have done justice to interpretation. These are other resources, and then the PowerPoints are attached in the slides. Okay, so thank you so much for taking out your time to watch this video. If you have any questions, you can just give me a WhatsApp chat. Give me a WhatsApp chat if you have any questions in the epidemiology. Give me a WhatsApp chat on +234 810 8614 225. Okay, just send a WhatsApp message, and then I'll be able to get back to you as soon as possible. You can also send me an email. This is my email address. Send me an email. Okay, I will reply to you as soon as possible. All right, so this is a basic overview of epidemiology in approximately 2 hours. All right, so thank you so much, and God bless you.